Hi viewers, welcome to LMS Solution. Today we are going to see about how to implement hybrid P&O and CS MPPT. So CS MPPT nothing but Cuckoo Search MPPT. So how we are going to combine that two MPPT P&O and Cuckoo Search, and also we are going to see the comparison between P&O MPPT, Cuckoo Search MPPT, and then hybrid P&O Cuckoo Search MPPT. So here you are seeing this. So this is a simulating model we developed for the hybrid P&O CS MPPT algorithm. So this model consists of PV array. Okay, so here you see that, right? So this is the PV partial shaded PV array model. So this PV array model having 4 panel, that means 4 PV cells. So PV cell 1, 2, 3 and 4. Okay. So here you see that, right, this PV cell having the rating of 50.04 watts, the open circuit voltage is 22.5, and then short circuit current is 3 amps, and voltage at maximum power point is 18 volt, and current at maximum power point is 2.78 amps. So this is a single PV cell rating. Okay, so we are connecting the 4 PV panel in series. Okay, so here you see that, right, we are connecting 4 PV panel in series along with the pi bus diode. Okay, so here you see that, right, we are measuring the current and the voltage of this 4 PV cell. Okay, so that will be used to inside the MPPT algorithm. So this current and this voltage measurement will be going to process via hybrid P&O and CS MPPT algorithm, and it will be generate the duty cycle. Okay, so this is a PV array detail. So next you can see that, right, so all that PV array or PV cell, right, operate at 25 degrees Celsius. So in order to create the partial shading condition, right, so here we are generating that that means we are changing the irradiation of the each PV cell. So here you see that, right, so here we are changing the irradiation from 300, 400 and 100 for every 0.075 seconds, right. At the time of 0 seconds we are maintaining at 300 watts per meter square. At the time of 0.75 seconds, so we are changing to 400. At the time of 1.5 second we are changing to 100 watts per meter square. So this is the first PV cell irradiation detail. So next you come to the second PV cell irradiation. So here also you will see that, right, we are changing the time in between 0, 0.75 and 1.5, and here we are changing the irradiation from 400 and then up to 0.75 seconds, right. So we are maintaining up to 0. That means 400. At the time of 0.75 second we are changing to 100. Okay, for PV cell, third PV cell, so we are changing from 600 and 700 watts per meter square, and then final PV cell the irradiation change from 200 and 500 watts per meter square. So this is a pattern we are, that means there are 3 pattern we are using. So for at the time of 0 second, at the time of 0.75 second, at the time of 1.5 second. So we are changing the pattern. Okay, for in order to create the real time scenario, that means for creating the partial shading effect of the PV cell. Okay, so next thing we are going to see about hybrid P&O and CS MPPT. So here you see that, right, so here we are providing the that means taking the measurement of PV voltage and current. So here we are measuring the PV voltage, PV current from this PV cell arrangement. Okay, and also we are providing another thing, nothing but the MPPT selection. So already I told, right, so we are going to test the 3 methods. So one is P&O MPPT, Cuckoo Search MPPT, and hybrid P&O Cuckoo Search MPPT. So not to select the MPPT logic, so here you need to provide MPPT selection command. Okay, so when you select 0, right, so it will be select hybrid P&O and Cuckoo Search MPPT. When you type 1 here, then it will select Cuckoo Search, and when you type 2 here, and then it will be select P&O MPPT. Okay, so when just I'm going inside, just go inside, right? So this is the arrangement of that P&O and Cuckoo Search MPPT and hybrid P&O and Cuckoo Search MPPT. Here is you see that, right? So we are passing that PV voltage and current to Cuckoo Search MPPT block and P&O MPPT block, right? So here you see that, right? So you are passing both the PV voltage and current to Cuckoo Search and P&O MPPT. So just I am clicking that Cuckoo Search MPPT. So this is a code for a Cuckoo Search MPPT. So here you see that, right? So this is a calculation of levy flight by using Cuckoo Search MPPT. Okay. So this is an important equation used in the Cuckoo Search MPPT. So based upon that levy flight calculation, so we are calculating the final duty cycle here. Okay. So this is a final duty cycle calculation by using Cuckoo Search MPPT. Okay. So what happened, right? So every sample, right, the Cuckoo Search MPPT will be generate the duty cycle. So based upon this, the levy flight calculation, okay, so the duty cycle going to be updated every sample of PV voltage and current. Okay. Then finally we are getting the duty cycle here. So next I am going to open that P&O MPPT. So this is a code for P&O MPPT. So here we are checking 4 conditions. So this is important 4 condition for P&O MPPT. That means based upon that change in power and change in voltage. That means you have to take the difference between the current instant voltage to previous instant and then current instant power to previous instant, and then you have to calculate that dV and dP. Okay. So change in voltage and change in power. So based upon the change in voltage and change in power, you have to increment or decrement the duty cycle. Okay. So this is known as a P&O MPPT algorithm. Okay. So based upon that PV voltage and current, the Cuckoo Search as well as P&O MPPT will be provide the duty cycle for hybrid operation, right? So here we are combining that both Cuckoo Search and P&O MPPT, and then we are taking the average of both duty cycle. Okay. So we are taking the just adding that Cuckoo Search MPPT output, and just we are adding that mean output of Cuckoo Search, the output of P&O MPPT, and here we are taking the average. Okay. So next process, right, we need to according with the MPPT selection, right? So already told, right, when you are type 0, then we are passing that hybrid P&O MPPT. When you are typing 1, we are passing only Cuckoo Search. When you type 2 means it going to be send only P&O MPPT. So for that we are creating the logic here, right? So here you see that, right, here we are comparing with greater than 1. Okay. If it is greater than 1, okay, so then it will be allow this logic. Okay. Greater than or equal to 1. That means when you have to allow Cuckoo Search MPPT, when selection will be equal to 1. Okay. So then what happened, right? So it will be allow this Cuckoo Search alone, and here also we are using another switching implementation, right? Here we are checking that same command, right? So it will be equal to 2, then it will be allow P&O, otherwise it will allow this output. Okay. So this switch will be used for allowing that Cuckoo Search or hybrid PO and Cuckoo Search MPPT. Okay. So if suppose signal will be 0, that means MPPT selection is 0, then hybrid PO and Cuckoo Search MPPT will be processed here and then it processed to this output. Okay. So when you input 1, right, then this Cuckoo Search duty cycle will be processed via here. Okay. So when that selection MPPT selection is 2, then it will be processed, that means P&O MPPT will be processed via here. Okay. So after finding that based upon the MPPT selection command, right, so it will be allow that three method, any one method, right, any one method from three implementation. So in this portion, right, in this portion we are calculating the duty cycle, that means, sorry, here we are calculating the V reference. Okay. So how we are going to calculating V reference, right, we are implementing here, right, so 1 minus d divided by d and multiplied with the V naught. Okay. So which is equal to V in. Okay. So we are taking the boost converter equation, so I mean boost logic equation, right. So we are boosting the voltage from PV side to that mean load side. Okay. So for that we are taking this kind of equation, 1 minus d divided by d V naught equal to Vn. Okay. So this Vn will be known as a reference voltage. So this voltage should be maintained across that PV cells. Okay, 4 PV cells, series connected PV cells. And then here you see that, right, we are taking the actual PV voltage. So this is actual PV voltage. So here we are having actual PV voltage, and finally we are getting the error voltage. So this is error voltage. So that going to be processed via PA controller, and then it will be generated the duty cycle. So we are getting duty cycle from the comparison of reference voltage with the PV voltage, and finally we are getting duty cycle. Okay. So this duty cycle next you have to process via PWM generator. So this PWM generator used to control this SEBI converter. Okay. So here we are using SEBI converter to connect the PV. That means here we are connecting this PV array to the load. So this is a load point. Okay. So by using this SEBI converter. Okay. So SEBI converter will be boost the voltage. Okay, according with the duty cycle from the MPPT algorithm. Okay. So now we are going to see the results. So here we are going to see the result of PV power, and then here we have to see about the duty cycle variation. So how the duty cycle variation happen in three methods. Now I am going to simulate this model. So now you see that, right, this blue color line, right, the blue color line is the peak point, global point for the particular partial shading condition. So how that different MPPT will be track that partial shading with respect to different partial shading condition. Okay. So now you see that this is actual PV power. So this is a global point. Okay. And then this is a variation of duty cycle. So here you see that, right, now system operated in the hybrid POCS method. So the system keep on, that means duty cycle keep on, here you see that, right, the duty cycle is keep on varying for tracking that optimal duty cycle. So now you see that, right, this point, right. So here you see that, right, the PV tracking that global point now by the hybrid POCS method. So here you see that this is a final optimal duty cycle around 0.3. Okay. So this is final optimal duty cycle obtained from the hybrid P&O CS MPPT. Okay. At the time of 0.75 seconds, right. So what happened, right, the partial shading condition pattern going to be changed. Okay. So now we are seeing the first pattern. So first pattern you will see here, right. First pattern will be 300 So here you see that first pattern will be 300, 400, 600 and 200. This is the first pattern, right? So second pattern will be 400, 400, 600, 200 and final pattern will be 100, 100, 700 and 500. So these are the three pattern we are supplying into that PV array in order to create the partial shading concept in the PV array. Okay. So now currently we are in the first pattern 300, 400, 600, 200. After 0.5 second it will be going to be changed to 400, 400, 600, 200. After 1.5 second it is going to be changed to 100, 100, 700 and 500. Okay. So this is a variation of partial shading patterns. Okay. So now the second pattern is changed now, you can see here, right. So the pattern will be changed at the time of 0.5 seconds because of that PV power generation is increased, that means this is a global point blue color. So now you can see here, right. So it will be reaching around that maximum power point. Okay, and also this is a variation of duty cycle for the particular pattern of the PV array. So you have to wait for up to 1.5 seconds, right. After 1.5 seconds, right, what happened, right, system goes to another pattern. Then we have to check that tracking of MPPT by means of hybrid P&O CS method. Okay. So we have to wait for that 1.5 seconds. So now you can see here, right, at the time of 1.5 seconds, right, the pattern going to be changed now. Now pattern changed to 3. Now we can see the tracking, right. So how the system is tracking now. So now it's go beyond that global point and then it finding that global point, that means tracking that global point. So it will take some time, okay, to reach that global point because of pattern change from 2 to 3. Okay. So it finding the optimal duty cycle. Okay. Now you see that, right, again it will be start towards to global point. Okay. So you see that, right, that PV power is start towards to global point. Okay. And also you can see here, right, so this it reaching towards to optimal duty cycle, right. It keep on increasing because you need to track that global point. Okay. So now you can see here, right, it reaches towards to global point now. Okay. After reaching that this point, right, you can see that variation of duty cycle here also. Okay. So now the system is tracked towards to global point now. Okay. So now it reaches that optimal value. Okay. So it now it will be track around that this point. Okay, not to maintain that peak voltage, that means global, that means PV power voltage towards to global power. Okay. So by using that hybrid PO CS method, that global point is tracked effectively, right? So we need to test the model with the Cuckoo Search. Okay. So just I am going to stop this one. I am going to change this method to 1 and then I am going to simulate again. I need to see the result now. So you have to wait for some time, so it will take some time to complete the simulation. Okay. Now you can see that, right, with the Cuckoo Search MPPT, right. So PV goes to that peak point, after that is coming down and then again it move towards to global point. Okay. By using Cuckoo Search we are not able to get the proper result. So at the time of 0.7 second pattern will be changed, but you can see here, right, even though in first pattern, right, Cuckoo Search not able to reach that global point. Okay. So now the pattern, second pattern is changed, right. So here also you will see that, right, pattern, this is a global point. Okay. But Cuckoo Search is not able to track that one, so is keep on that the same place, right, is maintained around only 50 watts. Okay. Because here you see that, right, that duty cycle not able to change. Okay. here you see that then Cuckoo Search, right, is not able to track that global point during pattern number 2. Here also you will see that right, duty cycle is maintained constant, so is duty cycle not able to change in order to track that global point. Okay. We will see for the pattern 3, during pattern 3 variation, whether that Cuckoo Search able to track that global point or not. So here you will see that, right. So this is variation of PV power. So this will be varying as like that hybrid P&O and Cuckoo Search MPPT. So it comes here, okay, this point, and here you will see that this is a variation of duty cycle in the Cuckoo Search. Okay. So the pattern, right, the PV power is coming down as like a hybrid PO CS method, and also it will be keep on increasing now. Okay. But what happened, right, it not able to increase, so it will be maintained around here. Okay. So here also you see that duty cycle is not able to move upwards, because during that hybrid POCS method, right, it is going to be reach around 0.45, around 0.45, but initially it will be start increasing, but after that it's not able to increase. Okay. So here you see that, right, it maintained around only 25 watts only, but global point is around here is 50, around 50 watts. So it's not able to track the power. Okay. So next I am going to change the method to PO method. So just go to select 2 and then simulate the model, and then see the result of the PV power and the duty cycle. How that PV power and duty cycle going to be vary with respect to P&O MPPT. And finally we are going to compare the 3 result. So how that tracking of PV power happened by means of P&O MPPT, Cuckoo Search MPPT, and then hybrid PO and Cuckoo Search MPPT. Okay. So after completion of the simulation, so I will show that comparison of 3 methods. So now here you see that, right. So this is the tracking of PV power under PO MPPT. So it tracked that global point for the first pattern, but it has some oscillation when you see that, right, this portion, right, it has some oscillation, but we try to keep track that global point. Okay. So here you see that this is a variation of duty cycle for the pattern number 1 under PO MPPT. So you have to wait up to 0.75 seconds. So after that the second pattern going to be vary. That means we are changing from pattern 1 to pattern 2 partial shading condition. Then we have to check the result of the P&O MPPT. So what happened to that second pattern? So here you see that, right, the result will be having oscillations. Okay, around that global point. Okay. So here you see that this is a result of 3 methods. So the first one is hybrid, and second one is . So this is for Cuckoo Search. Okay, so here you see that, right? Once again, so now you see that, right? This is the result of three methods. The first one is Cuckoo Search hybrid P&O Cuckoo Search MPPT, and second one is Cuckoo Search, and third one is P&O MPPT. So here you see that, right? In first pattern, right? So hybrid P&O MPPT reaching that global point, but Cuckoo Search is not able to reach that global point. Okay, and P&O also able to go to that global point, but you see that, right? In P&O MPPT it have some oscillations. Okay, in the pattern number 1, and second pattern, right? Second pattern also hybrid PO MPPT reaches to hybrid PO CS MPPT reach that global point, but Cuckoo Search is not able to reach, and P&O also able to reach that global point. Okay, and third one is third pattern, right? The third pattern hybrid PO CS algorithm will be able to reach that global point. So that will be that reaching that global point, right, after around 1.5 seconds, right? So that pattern will be changed at the time of 1.5 seconds. So it going to reach that global point around 2 seconds. Okay, so here you see that, right? Cuckoo Search is trapped at the local optima, and also you can see that, right? P&O MPPT is trapped at the local optima. So both CS and PO method is trapped at the local minima, but hybrid PO and CS algorithm able to track that global point easily. So here you see that this is a variation of duty cycle with respect to different pattern, right? Pattern 1, pattern 2, pattern 3 for hybrid PO CS method. So this is a variation of duty cycle for a Cuckoo Search. So this is a variation of duty cycle for a P&O MPPT. So when comparing these results, right? So hybrid P&O and Cuckoo Search MPPT providing better result than the Cuckoo Search MPPT as well as PO MPPT. So from that we can conclude that so hybrid PO CS method outperform than CS and the PO MPPT. So this is a result. This one result of P&O MPPT. So already I simulate that one is going on. So here you see that, right? PO is not able to track that global point at the pattern number 3. So this is a comparison of different MPPT, that means hybrid PO CS method and CS method and PO method. So how that MPPT will track that global point with the different pattern of the partial shading condition of the PV array. So thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.